Task number 1. We would like to generate a Fibonacci sequence of certain length that the user requests. So now, first of all, let's create a new Java project here. So let's say CSE114 Spring 16 Week 05 Lab exercise number 1. Okay, let's do that. And then we're going to create, first of all, a new class over there. So the exercise doesn't really tell, but you can simply say generates Fibonacci sequence. Okay, FibSeq. So that's like a short terms for them. And then with the main method there, and say finish. Okay, let's do one step at a time. So because we're going to prompt the user for, so if you look at the example output, so you're actually going to each time, well, somehow if you repeatedly have to prompt the user for something and do something accordingly, you have to wrap those actions inside the loop. So now, first of all, we need to read something from the user, so we need a scanner. Scanner input equals new scanner system dot in. Okay, and now, first of all, we're going to prompt the user to say system.out.println. Let's just sketch the idea, and then we'll see how we can make it more complete. So now, first of all, you're going to ask the user to say, enter the size of the Fibonacci sequence. Okay, and then the user is going to enter some number. So now we can say integer. What about just size? Equals input dot next int. And later on, we're going to read from the user yes or no. So in that case, we're going to have a mix of next int and next line. Remember, in the assignment instructions, I said whenever you have a mix, you have to say after every next int, input dot next line. Okay, there's some issue with the library. Nothing we can do about it. Okay, so after this, somehow we have to actually check to see if the size is valid or not. In the case where if the size is less than or equal to 0, okay, that's the error condition. So condition of invalid inputs. Okay, so when the size is less than or equal to 0, we simply cannot generate the Fibonacci sequence. Otherwise, we can. So otherwise, so this is the case where size is strictly larger than 0. So we will start with the sequence of size 1, 2, 3, 4, etc. In the case where size is less than or equal to 0, we're going to say system.out.println. And over here, you're going to say error sequence size must be larger than 0. Okay, so far so good. So far, not too bad. So now, if we manage to enter the else branch, that means the size will be at least 1. So in this case, we're going to initialize the array. Oh, wow. Array is the only data structure we will learn in this course. So whenever you need to store a collection of values, array will be the choice. But if you later on, if you go to 214, you got many more choices. But for 114, just array. So now we're going to create a sequence. What about, so what should be the type of the sequence? Integer, right? Because we start with 0 and 1 and then etc. So that'll be integer. Just one dimensional will be fine. We don't need two-dimensional array. Okay, you can see Fibonacci sequence. How about that? It's equal to new integer array and then just the size. Like that. Okay. So now I'm going to do some case distinction for you. So I kind of know the answer already, so I can tell you what the best solution might be to give you the minimum amount of code. So you can feel free to actually do your own version and check with me. That actually also works. I'm gonna show you the simplest way to do it. So first of all, so we're only going to distinguish between if the size the user enters is either 1 or something strictly larger than 1. Okay, that's something I'm gonna do. So I would say if size equal to 1 happens to equal to 1, that means it's a single element in the sequence. In this case, it will be very easy. You can simply say Fibonacci sequence 0, just only one element inside, is equal to 0. As easy as that. Okay, so now otherwise, so now you got to think about what this otherwise really means over here. First of all, we know that size equals 1 will go to the if branch. So if we go to the else branch, that means size not equal to 1. If not equal to 1, there are many possibilities actually. But remember, we are now in this outer else branch where size is strictly larger than 0. So if you think about these two conditions together, size not equal to 1 and size larger than 0. So what does that mean? That simply means size should be larger than or equal to 2. Okay, that's something you should really try to analyze yourself. It means that size larger than or equal to 2. Okay. So now, let's see how we can fill in the sequence. So now, in the case where size is equal to 2, then we can simply say, first of all, sequence at index 0 will still be 0. Okay, and then we also have at index 1, that should be 1. So these are the base cases. Okay. So now we're going to need a for loop to fill in the rest. So now, for example, let's say, let me turn on the lights and show you one example here. Let's say the user enters 5. So the Fibonacci sequence is going to be of size 5. So 0, 1, 2, 3, 4. And what we have just done was to fill in the first and second slots in the sequence. In this case, we have 0 and 1. So now we want to actually fill in the rest. So what we will do is, we're going to start with the third position in the array. Okay, and then to actually figure out what the value it should be stored in this index, in this position here, we need to look at the previous two elements. So let's say this happens to be I, the loop counter. Then we need to calculate the value of, let's say, sequence I by using sequence I minus 1 and sequence I minus 2. Okay, that's sort of the idea. And now once we have filled this in, let's say it will be 0 plus 1, which will be 1. And now when we move the loop counter to another position here, so I is equal to 3. The way to calculate that would be A2 plus A1, okay, which will be 2. And then to calculate this, it will be A3 plus A2, which will give you 3, and etc. Okay? So that's why in some ways very close to the sorted example we did today in the class. Very similar. Let's see how we can do that. So now we're going to write a for loop. So integer I, it's because we have done 0 and 1 already. So we can start with 2 directly. I less than, we can still go to the last elements in the array, that's okay. Because we need to fill in everything. Less than Fibonacci sequence dot length. I plus plus. Okay? So now, and now I'm going to ask you one question in a moment. So now, the way to figure that, to fill in the current slot at index I, Fibonacci sequence at index I is going to be two things, right? Yeah, exactly. I minus 1 and I minus 2. I minus 1 plus I minus 2. So now let's look at this for a moment to see if things are going to work. Let's say initially I is simply equal to 2. So Fibonacci sequence 2 is assigned to Fibonacci sequence 1 plus Fibonacci sequence 0. So that one's going to work. In the last case, where we're going to get I is equal to the length minus 1. In this case, it will be somewhere here. Okay? And that one is going to be this index minus 1 plus this index minus 2. Those two elements together. So it's going to work. So now, my question for you is, what if the size of this Fibonacci sequence here is simply just 2? What's going to happen? What if the user actually enters 2? In this else branch here, I said the size can be either 2 or 3 or 4 or and so on. what if the size is equal to 2? What's going to happen? And for you, what I would like to hear from you is, what happens to the state condition when the size is equal to 2? June, would you like to try? What do you mean doesn't work?
Because
Mm.
Fibonacci sequence length is 2.
Mhm. So I is initialized to be 2. So 2 less than 2 is simply false. The very first time you evaluate that. So for loop, yeah, maybe you wouldn't say it doesn't work. You would say the body of the for loop will not be even executed for once. That's what you want to say. Yeah, it works actually. Yeah, just that. Yeah. So basically, let me just repeat. So now, because we know that in the else branch in line number 19, the size is guaranteed to be 2 or 3 or 4 and so on. In a case where it is the size is equal to 2, we have done the setup for indices 0 and 1 already. In line number 20 and line number 21, we have done those 2 slots already. In a case where the size of the sequence is only 2, so that means this state condition here will evaluate to just false for the very first time, because the Fibonacci sequence length will be 2, and because we initialize that to be 2, so that will not even pass for the first time. So this means this will be skipped correctly. Okay? So to make it more explicit, it's actually very important. So we want to make sure we really understand why, in this case, it's so important to initialize the loop counter to be 2. So let's say if we simply have an array with a sequence of 2 indices. In this case, in line number 20, we set this to be 0. In line number 21, we set this to be 1. And there should be no further slots we can fill in, right? So that means the for loop should not be run even once. And this is the case, because we set the initial value for the loop counter as 2. Okay, very important. I can also write it down as a comment for you. So let's put a comment here. So we'll say that if size equals 2, then the body of the for loop below will not be executed at all. Okay, that's correct behavior actually. Okay, that's how we fill in the Fibonacci sequence. After this, we're actually going to print out the Fibonacci sequence. So now I'm going to do something. I'm going to ask you why it is not so correct. Okay, so now let me say I want to print out the sequence. The way to print out, very easy. So now we're simply going to we have to start from index 0, because we want to print out everything. I is equal to 0, I less than Fibonacci sequence dot length, and then I plus plus. And then we're going to say simply that, okay, integer I. So now, if you see from your handouts, the sequence start with angle brackets. So we can put it here. System.out dot print line. Oh, actually, they're going to be in the same line. So let's say print rather than print line. That would be better. And then we're going to say system.out.print some kind of Fibonacci sequence at I. Okay, I will fix that in a moment. It's not 100% correct yet. And after the for loop, we're going to close the sequence by using a right angle brackets or greater than. And in this case, we can say print line to say we want to change a new line. So now, all the elements are comma separated. So as you can see, in the sequence, every element should follow a comma, except for the last elements, right? So you can simply use an if statement to say if I is less than Fibonacci sequence dot length. Actually, I think this one would be better, maybe easier for you to understand. if it is not the last index we are looking at. Okay, in this case, we're going to say also system.out.print, just print, sorry. That shouldn't be print line, just print. And then we're going to print the comma followed by a space. So only the last elements we actually wouldn't put any comma. Otherwise, we'll put a comma. Okay, so now my question for you. Okay, as you can see, I put this printing Fibonacci sequence code under the else branch here. Do you think that's the right place to put? So somehow it seems like I will only print out the Fibonacci sequence when the sequence size is actually larger than or equal to 2. But what if it's actually equal to 1? Right? You can see now in the if branch here, there's no code there that says you have to print it out. Right? So now that's why we have to put this code here rather than here. We have to take it out and put it after this if-else statement. Because for this if-else statement here, we say either size is equal to 1 or it can be 2 or larger. But for both cases, we have to print it out. So that's why the code should really go here. So everyone sees what I'm doing? Okay, I'm just trying to explain that you should really try to print out the sequence no matter its size is actually either 1 or larger, right? Okay, that's about it. So now we haven't got into any like a while loop to ask the user for yes or no. I'll do that in the last step. That's something simple. Okay, let's try to see how this works. Enter size 0. That should really give me error, shouldn't it? Let's see. If that's simply 0, oh, next line, sorry. Let's try again. If I say 0 here, okay, error. Okay, sorry, I made a mistake. So after input the next int, it should be next line rather than next. If you put next, so please fix that. That was my mistake. Okay, let's try again. If you say 0 here, it's gonna say error. Okay, that's correct. Now if I say 1, simply 0. If I say 2, 0, 1, let's try a slightly larger one. What about 10? Okay, you can see 1 equal to 0 plus 1, 2 equals 1 plus 1, and 2 plus 3, 5, 3 plus 5, 8, and etc. So that's a Fibonacci sequence. The code seems to work, except that we would like to keep allowing the user to generate different Fibonacci sequence by prompting them for a new size. That's what we like to do. And it's so basically what we have done so far, we want to be able to repeatedly execute them. So that's why a while loop will actually help. So conceptually, I think we did something similar last time. So think about what we have done so far is this block of code over here. So you simply say enter the size of the Fibonacci sequence, and then we print out the sequence. That's what we have done so far. We would like to continually prompt the user to say either yes or no. They want to continue. So we're going to wrap it as the body of a new while loop. While something here, we're going to keep executing the same block. That's sort of the idea. Okay. So now we just have to introduce a new while loop and a new Boolean variable. And then to make sure at the end of the block, we're going to ask the user, would you like to continue, yes or no? That's the extension. After that, we're done. Okay, let's see how we can do that. So now, let me first introduce a Boolean variable here. So Boolean, user wants to continue. Initially just true, so we can at least enter the while loop for once. So while user wants to continue, and then curly brackets here. So we're going to put whatever we have done into here. Okay, I'll just put a comment here just to remind. And then now comes the critical points. So we're going to select everything from enter the size of Fibonacci sequence until the end of the else statement there. Okay, everything here. So that's where you actually print out the angle brackets, right? So do edits and cut. And now we're going to put it here, say edits and paste. So now the whole action now is part of the user wants to continue, which now has been initialized to true. But we must give the user the freedom to say whether they want to continue or they want to quit. If you didn't do that, so at the moment, this variable here will remain true all the time. Okay, so now that's why at the end, we have to say something like this. Sorry, here. Okay, let me put down comment here for you. And else. So now we're going to say system.out.println. Would you like to continue? Would you like to continue? In this case, string answer from the user will be input.next line. Okay, and now user wants to continue will be assigned to whether or not the answer is actually equal to true, equal to yes. Just Y. Anything else will be considered as a no. Okay, so now this will be the end of the while loop. And if we happen to exit from the loop, that means the user wants to continue has been set to false, which means they want to quit. In which case, we can say system.out.println, say bye. So you can see the way I'm trying to build it. I'm trying to build individual step first, and then to see how we can repeatedly execute that particular step by wrapping it as part of the body of another loop. Okay, that's how you should think of it. If you try to do the while loop first, it might get a little bit too complicated as you get to the middle. So I think this might be the best way for you to develop, at least in the beginning. Okay, let's try again to see if this might work. So now enter size. If I say 0, error, would you like to continue? Yes. Enter the size, 1. Would you like to continue? Let's say yes. What about 20? You can verify that. I'm pretty sure it's right. Okay. Would you like to continue? No. Bye. Okay. Any question about this? I hope it's not too hard. It should be reasonable, right? Okay. If you have no question, I'm going to stop recording for this part.